talk about function notation. So we're very used to seeing lines with equations written something like this. Y equals 3x plus 2. This is the general form of a line. Now when we use function notation, we don't use y equals. We use f of x. F of x equals 3x plus 2. Now this f of x is saying a function of x. So we can see here y is an equation based on x, but when we use this function notation, we clearly say that this equation here is a function of x. It's a function because each x value will spit out a maximum of one possible y value. If we put in an x value of 5, we'd have 3 times 5 is 15, plus 2 is 17. So that x value of 5 would spit out 17 as our y, or our f of x value. What's in the brackets is the variable. That's the unknown. It's a function of x in this case. If it was f of y, then y would be our unknown, or f of p, then p would be our unknown. We generally use f of x, and if we've already used f, we can use g of x, and then we can use h of x as additional letters so we can determine which function we're talking about if we've got more than one function option. So the only difference between our standard familiar notation and our function notation is instead of using y equals, we use the function of x is equal to. Now this is really helpful for us when we're looking at substitution. So if we consider this function of x, perhaps we want to know what this function of x would be if it was a function of 5 instead, which is what we just talked about. What this tells me is if I have a 5 in there instead of an x, everywhere my x was, I replace it with 5. So 3 times 5, and then plus 2. 3 times 5 was 15, plus 2, that was 17. So we can use this function notation to tell us what x value we should substitute in. We might see any value. We could have a negative value, function of negative 3. And once again, we substitute in everywhere there was an x. We saw x used to be a function of x, but now it's a function of minus 3. So we substitute in minus 3 where the x was. We copy our 3. Now, because we're putting a negative number, it's always a good idea to substitute those in brackets. 3 times minus 3 plus 2. 3 times minus 3, that's minus 9, plus 2 gives us negative 7. Now, we don't have to just substitute in numbers. We can actually substitute in other variables or little expressions. So, for example, we could substitute f of p. And what that tells me to do is everywhere I had an x, we replace it with a p. So we have 3, used to have x, now it's p, plus 2. That doesn't help us or change our function very much. It just means that our x became a p, and because it's not a number, we can't simplify that any further. But we can substitute in those values if we need to. We might also substitute in, instead of just a different variable, we might substitute in an entire expression. So instead of a function of x, we want it to be a function of a plus 2. And what that tells me is everywhere that I used to have an x, now I'm going to have a plus 2. So 3 times, because we're substituting an expression, we need to put it in brackets, 3 times a plus 2, and then we had plus 2 in the end. Plus 2 in the end, yeah. Now we can expand and simplify this one a little bit better. So 3 times a is 3a, plus 3 times 2 is 6, plus 2. That will simplify down to 3a plus 6 plus 2. That gives us 8. You can see here that when we have a function, in function notation, we can substitute in any given value by replacing the x with that function. We're quite familiar with substitution. This is just a different way of writing it. Let's have a look at another couple of substitutions. So we already used the function f of x. So because we've already used x, we're going to use g of x. G of x equals x squared plus 2x plus 2. Let's consider this equation or this function. We know it's a function because it's in function notation. Let's say I want to substitute in g of minus 2. Because we're talking about a negative number, we'll substitute in brackets. Minus 2 squared plus 2 times minus 2 plus 2 is equal to minus 2 times 2 is positive 4 plus 2 times minus 2. Oh, that's going to be a negative value, so we can do minus 4 plus 2. and that's going to equal 2. So this function, when we substitute in minus 2, g of minus 2, gives us 2. We could, once again, substitute in an expression if we needed to, or we could substitute in a different variable, and we would expand and simplify as much as we possibly can. So let's consider a different example. We already used g. Let's have a look at h. H of x is equal to, let's say, x squared plus 9x plus 14. Now, when we substitute a value in for x, we just pop it in for x. But sometimes we have a look at questions that give us something like this. What is this? This is what h of x equals, x squared plus 9x plus 14. But I'm also telling you that h of x equals 0. So instead of substituting in a 0 where the x is, we didn't do that. We're substituting in a 0 where the whole h of x is. This whole function is going to be equal to 0. Let's see if we could figure out what x was if the whole function was equal to 0. Well, it would look like this. We'd have x squared plus 9x plus 14. That's our function, h of x. And I'm telling you it's equal to 0. Could we solve that? Well, if we have a look at it, I can see that this is a quadratic equation. And because it's a monic quadratic, I can solve it using the sum and product method. So I'm looking for the two numbers that have a sum of 9 and a product of 14. And I can see those two numbers will be 2 and 7. Quick check, 2 plus 7, yep, that's 9. 2 times 7, that's 14. And now we can see we can use our null factor law because we're factored and our expression or our equation is null. It's equal to 0. So that tells me that one of these two factors has to be equal to 0. So either x plus 2 equals 0 or the x plus 7 equals 0. To find out x, I minus 2 from both sides. X could be minus 2 or minus 7 from both sides. X could be minus 7. So a little different from the previous examples. We weren't substituting in our x value. We were substituting in what the whole function was equal to. So we set it equal to 0, and then this one I made a little tricky because we had to use our quadratic equation knowledge to factorize it and then to solve it. But if our value is inside of the brackets, it becomes a function of 5 in this case, then we substitute 5 in where the x was. But if our value is outside of the brackets, or it's equal to the function is 9x squared plus x squared plus 9x plus 14, and that is equal to 0, we can set them equal like this. They're the same thing. And so then we can solve and we can find the possible x values would be minus 2 and minus 7. So when we're substituting in numbers, we can solve our equations or solve our functions. When we're substituting in things with variables or expressions in them, we can just simplify them as much as possible.